Hello and welcome to the Gaussian FlyThru project, part of the immersive lab sandbox. In this video, I'm going to explain what this project does, why I built it, and how it can be used to explore and interact with immersive 3D captured environments. At its core, the project is a browser-based viewer for .ply Gaussian Splat files, exported from tools like Luma or other photogrammetry apps. The scenes are generated by processing hundreds of photos into a cloud of points. These point clouds are created from thousands or even millions of points in a 3D space. Each of these points, known as a splat, has color, size, and other visual attributes. When all of those splats overlap into a dense cloud, they create the impression of a 3D environment. Consequently, when a camera is placed in a splat-dense environment, it appears photographic and immersive. However, if the camera is outside this dense environment, the illusion begins to break down, and you can see the point cloud more clearly. This viewer is designed to help explore these Gaussian splat environments in a variety of controlled, interactive, and useful ways. There are 4 main navigation modes. Orbit mode allows you to click and rotate around a point in the scene. This is useful for inspection because you can choose an object or area and move around it. Walk mode works more like a game-style first-person controller. You can move forward, backwards, left and right using the W, S, A and D keys. This makes it feel more like walking through the captured space. Look mode lets you look around the scene from a fixed point with the mouse. And finally, there's Flight Sim mode. This is a more experimental mode where you fly through the scene, steering with the mouse. Pressing W increases the thrust, pressing S reduces it. The mouse controls pitch and yaw. This mode provides the experience of piloting a camera through the Gaussian splat, which is useful for cinematic fly-throughs and exploring a space more fluidly. The viewer also includes a bounding box system. This lets you define a safe movement area around the scene. In Flight Sim mode, the bounding box can help keep the camera contained within the useful part of the capture, rather than drifting into empty or broken areas of the point cloud. Moving on to the tools, one of the main features is the bookmark viewpoints. This allows you to save camera positions around the scene as viewpoints. Each viewpoint has a label, thumbnail snapshot, and note. Once you have created multiple viewpoints, the viewer can connect them to form a smooth fly-through of the scene. There are additional controls for duration, timeline scrubbing, smoothing of aim position interpolation, and look ahead. So you can decide whether the camera looks directly between the saved points or ahead along the path, like in a flight simulator. Another key feature is the hotspots. These are labels placed directly in the 3D space, which can be used to identify objects, locations, research notes, design features, or anything else inside the capture. Each hotspot has editable text, a short label, a color, and a position. When clicked, it opens a text panel with more information. This makes the viewer useful not just for viewing a scene, but for annotating and explaining it. For example, it could be used for architecture, museum displays, heritage sites, medical or engineering documentation, exhibitions, retail spaces, or immersive research environments. The control panel on the left contains all the tools for setting up the scene. You can adjust the bounding box, align the scene, view camera position and rotation data, set a default camera, create and manage viewpoints and hotspots, and export or import your workspace. The workspace export is important because the .ply file itself only contains the captured splat scene. All of the extra settings you create inside this viewer, such as bookmarks, hotspots, camera defaults, bounds, fly-through settings, and annotations, can be saved separately as a JSON file. That means you can save and reload the same scene, restoring your setup without rebuilding it. In summary, this project is a tool for turning a series of captured images into an immersive, interactive environment. It allows the user to navigate through it, label it, structure it, create guided camera paths, record fly-throughs, and use it as a research or presentation environment. For me, the interesting part is how this sits at the intersection of photography, cinematography, game interaction and navigation, and immersive storytelling. It's not just about viewing a scan, it's about creating navigable experiences.